So next, we're going to look at solving a graph solution set for the polynomial inequalities below. Notice this time we've got 4 terms. And so we're going to do the same process first, make it equal 0. So minus x minus 3, no common terms. So x cubed plus 3x squared minus x minus 3 is less than or equal to 0. Okay. Okay, now think about this. How do I factor, how do I factor when I got 4 terms? Remember, I can factor by grouping. So I got to set this equal to 0. I'm going to factor by grouping, and I'm going to solve it. So I'm going to do parentheses on the first 2, parentheses on the last 2. I do it plus negative x because I want a plus sign in the middle. What does x cubed and 3x squared have in common? They have x squared. So I take out an x squared out of each of those. Negative x and negative 3. Well, remember when your leading coefficient is negative, I got to take out negative, so it'll be negative 1. Negative divided by negative is positive. Negative 3 divided by negative 1 is positive. Okay, and then they have x plus 3 in common. So then if I take that out, I'm left with x squared minus 1. So there's the factored form, but I could factor this further. Remember, x squared minus 1 can go further. So it'd be x plus 1, x minus 1. So I'll set that equal to 0. I'm going to solve each of those. Okay, and you could do this in your head. I'm sure you do this in your head a lot easier. And you're welcome to do that. I'm just writing it out. So set each binomial equal to 0. So x equals negative 3, subtract 1, x equals negative 1, add 1, x equals 1. Okay, so we've got 3 boundary points this time. 3 boundary points. Okay, so what I'm going to do is I'm going to make a number line. All right. I got to make sure I cover these values. I'll go a little deep. I'll go to negative 4. I'll go 1 beyond. Negative 2, negative 1, 0, 1, 2. Okay, and so I've got a boundary. I got negative 3, boundary there. I got negative 1. I got a boundary there. I got a boundary at 1. Okay. Now, what is this interval right here? Well, it starts at negative infinity. Now, I'm going to do something a little different here. And it ends at negative 3, but this time, well, I'll just do negative 3. At the end, I'm going to need to put a brace on it if that's an answer, because any number, any, not including infinity, any of these integers, if that's involved in the interval that's an answer, I'm going to have to put a brace on it because it does have an equal to. So that means it includes it when it equals 0. Here from negative 3 to negative 1. This is from negative 1 to 1, and this is from 1 to infinity. So those are my intervals. So next, what I'm going to do is I'm going to find values in those intervals for test values to plug into my function. So I'm going to do I'll do negative 4. So I'll just plug in negative 4. I need to write function notation. So negative 4 cubed plus 3 times negative 4 squared minus negative 4 minus 3. Okay. So negative 4 cubed plus 3 times negative 4 squared minus negative 4 minus 3 to be negative 15. So therefore, this one's going to be a negative. Okay. We'll do negative 2 for the next one. The next test value. So let's go up here and replace these with negative 2. That's positive, so it's 3, so that's positive. Okay, next one I'll use 0. That worked out nice. 0 cubed, 0, plus 3 times 0 squared, that's 0, minus 0, minus 3. Well, that's going to be negative because all that cancels. You're just left with negative 3, so that's negative. Now let's plug in 2. So let's plug in 2. So I'll delete the negative signs here. That's positive as well. Oh, yeah, that's positive, right? So I need to know the intervals to where, and let me write this down. I apologize. 2 minus 3 is 15. I need to find the intervals to where this value is less than or equal to 0. So where is it less than or equal to 0? Well, it's going to be this one's going to be it, and this one's going to be it. So from negative infinity to -3. Now remember, the -3 will have a brace because that's at that point it's equal to 0 at that point, so we have to include it. Union -1 to 1. I'm going to put braces on those because at -1 at 1 it's equal to 0, and we got to include all values that are equal to 0. By the way, not the best teaching part on mine. I'm going to show you graphically how this works. You could cheat on your graph actually to do this. Okay, I'll show you x cubed plus 3x squared. So I'm going to type this in here whenever I have it equal to 0. And I'm going to show you how to graphically tell what the solution is. Now, sometimes you have to adjust your graph a little bit. So to be greater than 0, or I'm sorry, less than or equal to 0, less than or equal to 0. What I'm asking here, when I have this less than or equal to 0, is when is your y, for what intervals of x, what values of x is your y less than 0? So less than 0 means I'm below, let me get a piece of paper here, this would be better. When am I below the x-axis? Because when I'm below the x-axis, my y is less than 0. So from negative infinity to -3, it's that way. And at -3, it's equal to 0, so I have to include it. And also from -1 to 1. And I include -1 and 1 because it's equal to it. So that's how you can tell graphically how to do that. I'll look at the graph, whether it's less than or greater than. If it was greater than, you would do the other two intervals. Okay.